Hello, everyone. Today's session will focus mostly on questions because without you understanding the type of questions that the CCNA course, the final exam is going to have, without you understanding the type of questions you are going to have encounter, how you are supposed to answer them, it will become very difficult for you passing the exam. As much as this course is about having a skill where you are able to understand how to deal with networks from the basics of designing, configuring, troubleshooting. That skill is very important. But the goal, you shouldn't forget the goal. The goal is to get certified. And to get certified, you need to know how to answer questions. And that's probably why we are doing this. All right, let's go. Unmute everyone. One, purpose of the OSI physical layer. Maybe we can start with someone had post 7 layers of the OSI just for the introduction to continue from the 7 layers of the OSI. If you can add function of each layer, that would be beautiful. And Carlos Nyarwata, Judith, Rufaro, Sharon Utete, unmute yourselves. This is a discussion. 7 layers of the OSI, if we can start there. That's the daily prayer. I'll wait.
Okay.
I have time.
So I think we have 7 layers. That is the physical layer, data link layer, the network layer, transport layer, session, presentation, and application.
Yeah, if you can add function of each layer briefly.
And maybe in brief, the physical layer, basically we're talking about the physical means of data transmission.
Data transmission. Layer
Then
number two.
on then layer number 2, we are talking of the NIC to NIC communication of data, ensuring maybe error-free transmission of data frames between maybe my devices. That is the
Okay, my network is a bit shaky, but if you can still hear me, uh,
yeah,
let's continue. I think we're on layer three.
yeah. The network layer, I think, basically provides the load addressing and routing of packets using the internet protocol, that is the IP.
Right? Layer three, IP
Mm,
addressing, IP addressing. Layer four,
Layer 4 is the transport layer. That is ensuring the data transfer between reliable data transfer between devices using protocols like TCP and UDP.
okay. Data segmentation. Layer five, six, and seven.
That is the session layer. I think this one maintains the connections between applications.
Initiation and termination of dialogues between two end devices, two communicating devices, and a presentation.
I think the presentation now converts data into format that can be understood by the receiving device.
Okay, data encoding, encryption, compression. Then the last one.
The application layer. This one, I think, it provides services to end user application. Examples may be HTTP, FTP, SMTP.
The application layer interaction with the user. More multiple answer for number one.
Yeah.
What is the purpose of the OSI physical layer? Data transmission.
Mhm.
Transmitting bits across local media. Is that one correct?
Yeah.
Which layer is responsible for
I
A?
think I would go.
Yes.
Which one is responsible for A? Controlling access to media. Which layer is that?
Is it not? Is not the data link?
All right, this is layer number two. Then performing error detection on received frames.
Is
Which
it
one?
not for data too?
Data as
Data
well.
link. I
Exchanging
don't.
frames between nodes over the physical network media. I think everything else is layer number
Data
two.
link. Yeah.
All right, let's go. Number two,
Mm.
why are two strands of fiber used for a single fiber optic connection? Two strands of fiber. All right, an answer. Spit it out.
They allow for flex connectivity.
A, B, C,
D.
D. Full duplex connectivity.
Mm.
Right, they increase the speed. Here we can work by elimination. Having multiple doesn't increase the speed. They prevent crosstalk. What is crosstalk and where do we experience crosstalk? This one is wrong. What is crosstalk? Right. Sharon is saying A. Someone else said A, someone else said D. Let's look at those answers. But my first question, what is crosstalk? And in which type of media do we experience crosstalk? I'm gonna Google lah. I'm wearing 4 to 7. You don't have to Google anything. Everyone of Google. What is crosstalk? Okay, when we talk of the copper, can I rub this off? No. When we talk of copper, UTP as a type of media, that's where we introduce crosstalk, where we have two wires, fields being created by data traversing each of those wires. The fields created, they interact with each other, therefore leading to losses. That is what crosstalk is. And how do we reduce or eliminate crosstalk? I hope I'm still audible. We reduce or eliminate crosstalk by twisting the UTP cables. That is why they are twisted. Am I still audible? My network is a bit messy. No,
Yeah, you're audible.
all right,
Yeah.
so that's what crosstalk is. So we eliminate that one. Let's go to right A. The two strands allow data to travel for longer distances without degrading. This is definitely not the answer. A. Having two strands doesn't affect the distance that is being traveled by the data. So our answer is to allow for full duplexity. Right, D. Let's go 3. What are the characteristics? What are the characteristics? Which characteristics describe crosstalk? I think those are double not towers. Give me an answer.
B.
B. The distortion of the transmitted messages from signal in adjacent wires, definitely. Kana pana mwanengo answer you can give us in the chat. Number 4, procedure used to reduce the effect of crosstalk. I think that's what I've discussed. Twisting, definitely this one, twisting. Requiring proper grounding connections, avoiding sharp bends during installation. Which type of media requires avoiding sharp bends during installation so that you can reduce the losses that you have? Which type of media is that? Let's look at E. Which type of media is this one? Which you should avoid bends? Someone in the chat, fiber, thank you. Then designing a cable infrastructure to avoid crosstalk interference. What type of infrastructure is this? Requiring proper grounding. So this one is out. This one is out. Wrapping the band of wires with metallic shielding. Shielding also helps with reducing some losses, but not crosstalk. All right, let's go. Match the following with the appropriate media. I think this one was matched. But let's just go through it and discuss. Backbone cabling in an enterprise network. Fiber. Why is it fiber? Backbone cabling in an enterprise network. What are we talking of when we are saying backbone cabling in an enterprise network? What is that? Let's describe different environments. Backbone cabling, guest access in a coffee shop, horizontal cabling structure, waiting rooms in a hospital, desktop, then long-haul networks. The first one is fiber. Why? Why not copper? Why not wireless? I think when you are answering these questions, you need to be very curious. If you just answer a question A, B, C, D without thinking why the other answers are wrong, that is probably a wrong approach because Palomino's end exam, a question might be asked differently. Even if my answers are on Ari Postil, that question can be asked differently. So I think that might cause problems for you. What happened there? So learn to analyze my questions. Looking at my questions are wrong. My answers are wrong and why they are wrong. Asking questions like why we are using fiber for backbone cabling. Main reason I can think of is because of capacity. Because if you are talking of the backbone, that is where all the traffic is going through for an enterprise, a big company. So you need some type of media that has enough capacity to handle the type of traffic that you're going to have there. Then guest access in a coffee shop, wireless, mobility. We are in a coffee shop. I think everyone needs to be mobile. We don't have too much information that needs to be transmitted. We don't have a lot of distractions in the guest house, in the coffee shop. Basically, I think wireless could be a very good choice for that. Longest access point and everyone gets connected. Horizontal cabling structure, that's copper. Question mark on this one. Waiting rooms in a hospital, wireless. I think same explanation as for the guest access. Desktop PC in an enterprise office, that should be copper. Our offices, our desktops, they are connected via copper cabling. Then long-haul networks, definitely fiber because of one, the capacity, and most importantly, the ability to transmit over long distances. This one, question mark, because I can't think of anything else why they use copper for the horizontal cabling structure. I think probably fiber will be a very expensive type of medium for that. All right, let's go to number 6. A network administrator is measuring the transfer of bits across the company backbone. The administrator noticed that the network throughput appears lower than the bandwidth expected. Define throughput, define bandwidth. Anyone to give it a try? What is throughput? What is bandwidth? I think in the notes, they added good. It should be good put. Define throughput and bandwidth. What's the difference between that? Anyone? You can add good put to that as well. What's the difference? What is bandwidth? Okay, let's start with bandwidth. What is bandwidth? Teroepa Google, I would appreciate an answer from anyone. What is bandwidth? Okay, someone in the chat, capacity, exactly. The bandwidth is the capacity of a channel, capacity of the media. When we're talking of specifics, fiber is the most capacity of the wired, even the wireless media that we have. It can carry more data than any other types of media. That is the capacity. All right, let's look at the throughput. I gave an example. I think in the notes I gave an example of I think I gave an example of a highway. Let me start by defining the bandwidth. Let's say we have a highway, 8 lanes. We can have one in a 2 lanes. We can have in a 4 lanes. We can have in 8 lanes. In 8 lanes, you need more capacity because more vehicles can traverse in one or the other direction. That is the bandwidth, the capacity of the highway. What defines the throughput? Using the analog highway, 8 lanes, 8 cars, 0 famba simultaneously in one direction. Define throughput. Definition, a throughput, Google. I need people to be active. Go behind the scenes. What are you doing? Or kana musiri kuziva motaura kuti we are definitely out. I need some kind of participation, even in chat.
Hello?
Vanhu ngaende paGoogle, do something. Yes. Throughput.
Sorry, can you come again on the example ya mamuchi break?
Yeah.
For my end, yanga break a bit.
Okay, the example to best explain those 3 is on a highway. When we talk of the bandwidth, that's the capacity. We have 8 lanes. If we have 2 lanes, capacity, let's call it 2. If we have 4, capacity 4. 8, we have capacity 8, meaning we can transmit more data. We can move more vehicles. More vehicles can go through the highway, different lanes, each using each vehicle using its own lane. That's the capacity, the carrying capacity of the highway. That's the bandwidth. So the more lanes we have, the more bandwidth we have, basically. Now we want to define throughput. Let's get the definition of throughput and use the analog highway to see what throughput is. Anyone to read the definition in Google? Just waiting for participation. Everyone is not muted. Participation.
So
yes, throughput.
Throughput is defined as the amount of data that is successfully transferred through a network in a given amount of time.
Right.
So I think from your example,
keyword is successful there. Go to the analog. Use the highway. Can you try and use the highway?
So according to the highway, right, since we said bandwidth is 8 because bandwidth is the maximum amount, right? So I think throughput would be probably at that time, there are probably 2 lanes being utilized. So that would probably be the
Right.
throughput.
Throughput is if all 8 lanes have 8 vehicles in each lane, 8 vehicles, 1 in each lane. But if this is the starting point, this is the destination. Kunoku kwasumuka 8 vehicles, but dzimwe dzobondera, dzimwe dzoita stuck in congestion, kunoku kwasvika 5. 5 defines the throughput, the amount of data which is successfully transmitted. That is what throughput is. So 8 is the capacity. The capacity does not define the amount of data which has successfully been transmitted. So 5 is the throughput. The keyword to define throughput is successful. Right, let's go to good put. Give us the definition, then we get to the analog. It might sound simple now, but this is the typical things you get in your exam. Good put. Anyone else? I don't have the definition in my head. Chakapa Google. Chakapa Google, Chat GPT, whatever it is. What is good put? Using Gemini. Vamwe vese ite hatizivi tinzwa. I think a couple of guys left. We have Farai. We have Carlos. Carlos, I've never heard you speaking. Unmute yourselves. Anyone? Okay. Using the analog.
Okay.
Okay, give it a try. Give it a
Okay, on the good okay, on the good put, I would define good put as the amount of the successfully transmitted.
amount of
And
what?
useful data that
Useful.
data that has been successful.
Exactly. Useful. And the keyword here, the keyword is useful. All right, the keyword is useful. For throughput, we focus on successful. Here we are focusing on useful. All right, capacity, we started with the capacity is 8, but only 5 vehicles managed to reach the end. But of those 5 vehicles, what we're expecting are only red cars. And out of the 5, we have 2 blue cars and 1 red car and 2 green cars. So therefore, our good put would be, what did I say? 2 red cars, only 2. Even if 5 vehicles reached successfully at the end, the vehicles we were expecting to see are only the red ones. So meaning we started with 8, which is the capacity, right? Probably 8 vehicles at the starting point, 5 at the destination. But what we are looking for are the 2 vehicles that arrived with the color red. So in terms of data now, you will see when we talk of good put, not all the data that we've successfully received is useful. We might have some data with some errors. Rasvika to the destination, but rine error, right? That means that's a problem. Reducer our good put. Data redu rasvika to the destination, but rine overhead, a lot of overhead. So when we talk of data encapsulation, we talked of adding my headers and my trailers to our data. So starting with the application layer, we had data. Then we added a trailer and a header at every layer. So at layer 4, then at layer 3, then at layer 2, another one. Header and trailer as well. Right? All these headers and trailers, they can be successfully transmitted though reach the destination. But is it our data? No, it's not our data. Our data is this small thing that is right here. So good put basically is the useful data that has been successfully transmitted. So bandwidth inogona yakawanda, throughput is less than that, and good put is far much less than that. That defines those three things. Right? The question now was which 3 factors could influence the difference in throughput? The difference in throughput between let me try to do this. Right, the administrator notices that the network throughput appears lower than the bandwidth. Why would it appear lower than the bandwidth? Go through the answers. A, the amount of traffic that is currently crossing the network. Which 3 factors? The amount of traffic. B, the sophistication of the encapsulation method applied to the data. B definitely applies to the good put. The type of traffic that is crossing the network, the latency that is created by the number of network devices, the bandwidth of the WAN connection to the internet, the reliability of the Giga Ethernet infrastructure backbone. Anyone to give it a try?
I think A, yeah, and C
A,
as well as D.
A, C, and D. Right.
D.
The amount of traffic that is currently crossing, definitely, yes. This one can affect the throughput. If you have less traffic, therefore the throughput will be less. Right. C, the type of traffic that is crossing the network. Explain that. Explain the type of traffic that is crossing the network. You gave us the answer. Explain how does it affect the throughput?
I think type of data dzatinadzo likes of mavid texting, so kana zvichitransmitwa oneneta zvinogona kuremera chi
Robonaita say? Okay, the answer is correct, but I was waiting for the explanation. I didn't get that clearly. And the last one, the latency that is created by the number of network devices that the data is crossing. This one is correct as well. But I was waiting for the explanation. Why are those answers correct? Why are the other ones not correct? That's the curiosity I was talking about. When you answer these questions, don't just copy paste, for example. If you go to the internet, you'll find these answers. But question why? Why is that an answer? And why is that not an answer? Because if you can relate those 2 things, then it means you have completely understood the concepts behind whatever we are dealing with here. Okay, I'll leave the why here because I think to explain and analog. Let's just completely end this one. Number 7, characteristics of fiber. Definitely A, not affected by EMI. The reason why is because of the core cladding interfaces that the fiber has. I'm not going to look at every other answer. All right. Number 8, what is the primary role of the physical layer? What is a primary?
Let's say that we choose to have.
You want to choose? Okay, 2.
Vakanzi-
Okay, I didn't see that. 2, each pair of cables are wrapped. No. It combines technique of cancelling. No. Typically contains 4 pairs of fiber. No. More expensive than UTP. Yes. A and E. Voila. Thank you very much, Sharon. I think A and E. Let's go. What is the primary role of the physical layer in transmitting data on the network? Creates the signals that represents the bits in each frame onto the media. Question mark. Provides physical addressing. No. Which layer provides physical addressing? Layer 2. Thank you. Right. Determines the path packets checked through the network. This is layer 3. So no. Control data access to the media. Data access to the media is controlled by layer number 2. So I think by elimination, A is the answer. Create the signals that represent the bits in each frame onto the media. Definitely. The reason why the question mark is because every time I see frame, I see layer 2. But I think that is definitely the answer A. Number 9, with the use of unshielded twisted pair, question A, okay. With the use of unshielded twisted pair wire in a network, what causes crosstalk within the cable wires? We've answered that one. The magnetic field around, yes, around adjacent pair of wires. The use of braided wire to shield, no. Reflection, no. Collision, no. Right? What type of cabling is shown? That is coaxial cable. C. In addition to the cable length, what 2 factors could interfere with the communication carried over UTP? All right, we definitely have crosstalk, the bandwidth. Okay, this is the correct answer. Let me do this instead. Bandwidth, question mark. Size of the network. It might affect what 2 factors could interfere with the communication? Signal modulation technique? No. Electromagnetic interference? Yes. So I think this makes a lot of sense. They might interfere with the communication carried over UTP. Crosstalk, definitely. Electromagnetic interference, definitely. Fiber, on the other hand, no crosstalk, no interference. That's why it's the best physical medium that we can have. Refer, what type of cabling is that? This is UTP. Twisted pair. This is the pair that is twisted right there. So that is UTP. Dipump and a shield. Then we would have talked of STP, shielded. Right? Let's move. Which 2 devices commonly affect wireless networks? All right, wireless networks are affected by devices that operate at the same frequencies as our wireless signal. So 2 devices, 13D, microwaves, definitely, cordless phones, home theaters, Blu-ray players, external hard drives. I eliminate this. What is this? Incandescent light bulbs. I know fluorescent. C, cordless phones. I'll take this one. Home theaters, do they have any type of waves that they have? I guess not. Choose 2. Any other answers? No, they don't. Okay, so let's take those. Let's take those 2. Right. Which 2 statements describe the services provided by the data link layer? The data link layer is responsible for framing, MAC addressing, MIDI access. So it defines end-to-end delivery, addressing screen, no. It maintains the path between the source and the destination, no. It manages the access of frames to the network media access. It provides reliable delivery through link establishment and flow control, no. The other one, D. Are you sure? C and D. This is Sharon. Let's see. It ensures the application data will be transmitted. No. It packages various layer 3 PDUs into a frame format that is compatible with the network interface. I think I can relate more to this one. So between C, D, and F, which one do we eliminate? Not sure about D. Me as well, not sure about D. All right, I think time is up. It's definitely C and F on this one. Join me in the next video. How many questions do we still have? Quite a lot. Huh? I think the next one will finish.